In this lesson, we will solve rational equations. And as a reminder, a rational equation is just an equation that contains rationals, which are of course just fractions. Typically in a rational equation, part of that fraction in the denominator will be a variable of some sort or an expression of some sort that contains a variable. We really have two choices. If we only have two terms and they are set equal to each other, the easiest way is to cross multiply and to solve the resulting equation. Most likely, however, we will have to do method 2, which is when we have 3 or more items. Just as we did with clearing fractions, we find the least common denominator and multiply every value by that denominator. One thing to also point out as we start solving rational equations is the domain. So a domain of a rational equation is all of the values that x could possibly be. And the reason that we do this is sometimes we find the solution to the equation, but then find that the solution is one of our restricted items in our domain. So when we restrict the domain, we're looking at the denominators and asking ourselves, is there a value of x, or whatever our variable is, that if we plugged it in would make that denominator 0. So looking at 3x, obviously if I plugged in 0, the denominator would be 0. Looking at x, if I plugged in 0, the denominator would be 0. So that means I don't want x to be 0. So if I write my domain, typically I could write it in two ways. I could write the domain is all of the x's such that x does not equal 0. And sometimes we throw in there that x is a real number. Typically, we would just write this as from negative infinity to 0, but not including 0, union 0 to infinity. This is the way I typically will write it. So what that means is when I get to the end of this and I find my solution, if that solution is 0, then I say no solution. I don't say the solution is 0. In order to solve, I now have to look at my least common denominator. So just as you would with a normal fraction, I would start with the constants. I would look at 3 and 6 and say, what's the smallest number that 3 and 6 go into? Which would be 6, because obviously 6 does not go into 3 evenly. Then I will look at how many x's I have, and I'm looking for the most number of times that x occurs in just one term. So it occurs once here and once here, so the most number of times is once. That is my least common denominator. What that means is I'm going to take each of these terms times 6x. So just as we did with our clearing fractions technique, what's going to happen is those fractions are all going to go away. On the first example, 6x and 3x, the 6 and the 3 would reduce to 2 and the 1, and then of course my x's would go away. So 2 times 1 is 2. For my second term, 6 and 6 would go away, which leaves me with 5 times x, or 5x. And for my last term, x and x go away, which leaves me with 2 times 6, or 12. So now I've taken an equation that was kind of complicated to begin with, multiplied it by the least common denominator, and now I have a simple two-step equation that I can solve fairly easily and find that x is 2. Again, we can do that check to plug it back in. Typically, if we have that x is 2 and we know that the only restriction is that x cannot be 0, the check is going to work out. But let's go ahead and take a look. 1 times 3x plus 5/6 equals 2 over x. So this is 1/6 plus 5/6. Does that equal 1? Yes, 1 equals 1. So it checks out. This is one of those first example equations where, as you can see, I only have two terms on each side, or one term on each side, which means I can just cross multiply to solve, which will be easier than finding the least common denominator. Let's go ahead and restrict that domain so I know that y can't be what value would make this 0, which would of course be -5. And if you're unclear how to do that, all I'm doing in my head is setting this equal to 0 and saying what would make that expression equal to 0. In this case, it would be -5. for the other one, again, I'm plugging it in and setting it equal to 0. And we've done a lot of this when solving quadratics in the past. So you don't have to show any of this work. You can do all of that in your head. But those are the two values that y cannot be. So if I get to the end and y is one of those values, there's no solution. The domain, again, I would probably write that as negative infinity up to negative 5, union negative 5 to 2/3, union 2/3 to infinity. And now I'm going to cross multiply. So 3 times 3y minus 2, yes, I put it in parentheses to remind me to distribute, and then 3 times y plus 5. I could go ahead and divide by 3 on each side at this point, which would make it easier. Most probably wouldn't see that, so I'm going to go ahead and distribute. 9y minus 6 equals 3y plus 15. Subtract your 3y from each side. And now divide by 6. In this case, again, I would not want to write this necessarily as a decimal. We tend to like to keep things in fraction form. And so I'm just going to divide the top and the bottom by 3, which gives me 7/2. I would probably leave that the answer like that. Pay attention to how Alex asks you to leave your answer if they want it as a mixed number or an improper fraction or a decimal. I did skip the check on the last question just because I was running out of room. Feel free to go ahead and do that check. In this case, again, I'm looking at my domain first. The domain would be all of the values such that a was not 6, because if I plugged in a 6 here or here, that would make the denominator 0. Now I'm going to multiply everything by the least common denominator, which would be a minus 6. So I'm going to take every term times a minus 6. So what happens is those a minus 6's cancel, which gives me 2. This one gives me negative 5 times a minus 6. And my last one is 2 times a minus 5. Now this is a fairly simple equation that I can go ahead and solve. Be careful for that double negative on the left side. I will go ahead and subtract the 2a from each side. Now that you're in MA 102, it's okay to not show every single step, but know that I am subtracting the 2a, which gives me negative 10, and negative 7a, and that would be 32. Now if I subtracted the 32 from each side, I would have negative 42. Again, only do this if you're comfortable with it. Notice I'm just showing less work on this question. Divide by that negative 7, and I get a is 6. Now here's where I have to be careful. I said at the beginning that my domain was everything except for 6, which would be negative infinity up to 6 and 6 up to infinity. But I just found that my solution is 6. And so what that means is this is a no solution question. If I plug 6 back in, notice I would plug the 6 in as the denominator. 6 minus 6 is 0, so I'd have 2 over 0, which is undefined, which is why there's no solution. This one is a little bit trickier, finding that least common denominator. Let's look at our domain first, how to restrict that. I know here that if I don't want y to be 1, because 1 minus 1 is 0, I don't want y to be negative 3, because negative 3 plus 3 is 0. Now I'm going to look at this trinomial and factor it, factor the quadratic. I'm looking for numbers that multiply to negative 3 that subtract to 2, which would be positive 3 and negative 1. So that factors into those two same terms that I had before. So this is my domain, which would be negative infinity up to negative 3 up to 1, not including 1, and then 1 on to forever. Now, when I multiply everything by the least common denominator, the least common denominator will be y plus 3 and y minus 1, because y minus 1 happens once here and once here, so the most number of times is once, and y plus 3 happens once here and once here, so the most number of times is once. Instead of writing that and making this look very, very complicated, let's just try to reason through without writing every step down. If I multiplied this fraction by this, that y minus 1 term would cancel out, and I would be left with 1 times y plus 3. On my second term, my second value here, the y plus 3 and the y minus 1 would both cancel out, and that would leave me with just y plus 1 on the top. On my last term, y plus 3 is the denominator. That would cancel with this y plus 3, leaving me with 1 and y minus 1. And now I would simplify. This side is 2y plus 4. This side is y minus 1. Subtracting y from each side gives me y plus 4 equals negative 1. And subtracting 4 from each side gives me y is negative 5. That does seem to be a solution that would work, so that is my solution. Notice negative 5 was not one of my restricted values. Here are two for you to try. Again, pay attention to the domain of each of the functions, so try them both and then press play to check your work. For the first, I'm going to restrict my domain to x cannot be negative 3. I'm going to multiply everything times x plus 3. Again, feel free to write all of that out. And on the two fractions, the x plus 3's will cancel. For my first term, I have x plus 6. For my second, I have negative 2 times the quantity of x plus 3. And then I have 3, because the x plus 3 canceled. Again, on the left, I'm going to distribute. Then I'm going to combine like terms. X and minus 2x is negative x. 6 and negative 6 is 0. I would then divide by negative 1 to get x equals negative 3. In this case, I said that x can't be negative 3, so I'm going to instead say no solution. For my second question, again, x cannot be 0. I'm going to multiply everything by the common denominator, which appears to be 12x. In this case, the 12x and the 3x would reduce to 4, which leaves me with 24, because 4 times 6 is 24. In this one, 4 and 12 would reduce. I would have 5 times 3 times x, or 15x. And in this case, the x's would cancel, which gives me 36. I would subtract 24 from each side, and then I would divide each side by 15. And instead of turning that into a decimal, I would reduce by dividing by 3 to leave me with 4/5. And because that was not 0, that's my solution.